Hi, everybody, and thanks for joining our quasi-informational cyber seminar series on the 2019 National Water Center Summer Institute. I'm Danielle Tiarina with Quasi, and I'm joined by Trey Flowers, who is the Director of Analysis and Prediction Division at the National Water Center in Tuscaloosa, Alabama. And he is the lead for the development of the National Water Center, and that's what his division does. And so this is the second webinar of the Summer Institute series. And in this webinar, we will give an overview of the collaboration between Quasi and the National Water Center. And Trey will also address the goals and activities at the National Water Center and how the Summer Institute fits into exploring these goals. And just a couple of housekeeping items. We really encourage you to ask questions, and you may do so at any time in the chat box in the GoToWebinar control panel, and then we will address them all at the end of the talk. And if you have any issues during the talk, feel free to chat with the Quasi organizer or put your hand up, and we'll try and do whatever we can to help you out. So with that, I will go ahead and hand it over to Trey Flowers.
All right, thank you very much, Danielle. Go ahead and get started. So I usually like to start telling our story with why are we here? And this slide is from the World Economic Forum in 2017. And this forum gathered a group of international experts and essentially asked them the question, what keeps you up at night? What do you see as the world's largest problems? And in 2017, they plotted what they came up with in the Economic Forum on a scale of likelihood on the x-axis and impact on the y-axis. And they found that extreme weather events, natural disasters, and water crises had the highest likelihood of occurring and would have the highest impact on world population. The National Weather Service, that's the parent organization for the Office of Water Prediction and the National Water Center. We've recognized that this is a concern for going on about 7 or 8 years now, and the Weather Service has one strategic outcome, and that this essentially drives everything that we do at the Weather Service, and that is to create a weather and water ready nation. This started out as a weather ready nation, and in the last president administration, it was recognized that in order to be weather ready, we really must be water ready, and that means to build resiliency in the face of increasing vulnerability to these threats that are later identified at the World Economic Forum. And something that is hard for a technical person like me to come to grips with, it's not just our ability to produce a forecast. In 2011, the National Water Center is in the beautiful city of Tuscaloosa. In 2011, the city of Tuscaloosa was affected by a tornado outbreak. This was the same tornado outbreak that affected Joplin, Missouri, that around the same time. And for that tornado outbreak, we had about 45 minutes of lead time in the forecast. We issued watches, we issued warnings, told people to shelter in place, and still we had an unacceptable loss of life due to that outbreak. And the point is that we can do we can have a good model that produces a good forecast, and if we're not able to communicate that information in a way that people can understand and take action on, we have ultimately failed as an organization. So what are we doing to help address this? And this is the current state of the water forecasting capabilities in the National Weather Service. National Weather Service, we have local weather forecast offices. We have 122 of them spread throughout the country. They're the ones who provide the authoritative forecast information that your TV meteorologist uses to give their news weather forecast. There's a similar mechanism in the water side. So those of you who have seen flood watches and flood warnings in your local area, that's generally the forecast is generally supported by a river forecast center. And the domains of the 13 river forecast centers in NOAA are shown in this slide. Each river forecast center has their own unique take on how to approach the problem. They are relying on models that were the technology was originally developed and conceptualized in the 1970s. So they're fairly old models. Each individual forecast region has their own take on it. There's no continuity between one river forecast center and the next. And we recognize that in order to build a weather-ready nation, we have to evolve from from this way of doing things into the next generation way of producing a forecast. We recognize that in order to meet the growing water challenges of our generations and future generations, that we need to do a better job. Population is growing. It's growing in areas that aren't necessarily water abundant, like the states in the West. Climate change. We don't really fully understand how climate change is going to affect our water supplies. We have an aging water infrastructure. So a lot of the water infrastructure in this country was built in 60 to 70 years ago at this point, and it's getting past its serviceable lifetime. So there's been this growing impetus for change. We recognize that we have old systems, not just in our modeling and our infrastructure, but we're not doing things in a 21st century way. And in 2012, the National Academy of Sciences examined the National Weather Service's water forecasting operations. And this was a very difficult report for us to take because it didn't really paint us in a flattering light. There's a significant gap. They recognize there's a significant gap between the state of the science and what we were currently doing in our operations. We have our forecasters very much in the loop in our current river forecasting centers. What we mean by that is they will manually adjust the forecast based on their local knowledge. They'll take what their model is giving them and they will say, well, I don't really believe this. I will go ahead and manually adjust the forecast. And that's fairly dangerous for us as a forward-leaning scientific organization of the 21st century. And as is important to the students that we would consider for the Summer Institute, we don't have, at least in 2012, there was an identified need or a lack of skill in modern science, modern hydrologic science, modern programming techniques, and these things were very alarming to the administration at the time, and they set out to change things. So the Office of Water Prediction, the parent office of the National Water Center, engaged in a roadshow where we went around the country. We talked to anybody that would talk to us. We went to river basin commissions and user forums. We talked to our federal government partners. We talked to local governments, state governments. We had regional and national conversations on water. And we asked these stakeholders, what are the things that keep you up at night with respect to your water resources? And ultimately, these stakeholder groups came to us with several themes. They were worried about flooding. the quality of their water, the availability of their drinking water supplies over time, drought and its impacts on our food security, climate change, and the uncertainty that lies ahead. And the one thing that really rose to the top out of all of these stakeholder engagements was there is a need for unified, integrated understanding of near and long-term outlooks and risk, that we needed to provide consistent, very high-resolution, integrated water analysis and provide actionable water intelligence to meet these concerns. So the government works in mysterious ways sometimes, and based on all this feedback, we came up with and received funding from Congress to stand up several new capabilities. One of those was a demonstration of centralized water forecasting. This is the national water model that we'll get into in quite a bit of detail here in a few minutes. The other is in 2016, we received funding for enhancing our water prediction capability through very high resolution street scale modeling, real-time flood inundation forecast mapping. This is a capability that the emergency management community has been asking for decades. Right now, when a flood watcher warning is generated, it's based on a county by county basis in most cases. We recognize that there is a need for a flood inundation forecast map. And then this is now reality. This slide is a little old. Standing up the operations center at the water center. That is just happened this year. The operations center, that is essentially our customer service arm. So when water events happen, we are able to provide intelligence directly to our primary customers. So the water center, we talked quite a bit about Tuscaloosa and the water center in last week's webinar. The water center was originally conceptualized as a virtual meeting space where the nation's water experts would gather to solve water problems. And it evolved from that virtual center into being a true physical space where we can collaborate. It's located in Tuscaloosa. It's where I'm speaking to you from now. And it really is a center of excellence for responding to our water resources challenges. The flagship product that we develop out of the National Water Center, this is where I spend about 80% of my time leading the development of this particular product. That is the National Water Model. And the National Water Model is a quantum leap forward from the state of play as it was in that I showed you in the map of the 13 river forecast centers. This is it is the first of its kind continental scale water resources model for the United States. It produces a forecast at 2.7 million river reaches across the country. We produce a short range forecast every hour that goes out to 18 hours. We produce a medium range forecast 4 times a day that goes out to 10 days. And in the next version of the water model that'll be released in February, March timeframe, we will, for the first time, be generating a probabilistic ensemble forecast in the medium range. We have a long-range forecast that is already probabilistic. We run it on 13 ensembles, and we run that once a day. So, comparing and contrasting to our existing capabilities, this is now a nationally consistent, high fidelity, high resolution water forecasting tool that is currently under development. It gives about 3 orders of magnitude more actionable intelligence for the country than was available previously. Right now, we generate a forecast on approximately 4,000 locations across the continental U.S. With the water model, we're extending that to 2.7 million locations. We are able to provide that intelligence in locations where that intelligence was not previously available. So, looking at the figures on the right of the slide, the red dots are where we currently are able to provide a forecast. The blue lines, the blue areas in the figure in the upper right, that's where the National Water Model is able to provide a forecast. This is shown in a little more detail in a region in the figure in the lower right-hand corner. The red dots are our current forecast locations. This is Kentucky, Tennessee, Mississippi, and Alabama on the right, and Missouri, Arkansas, and just the barest corner of Louisiana on the left. This is a regional cutout of the Mississippi River, the largest waterway in the country. Right now we only produce a forecast at the dots. The National Water Model provides the forecast along the blue lines. So, what is the National Water Model? It was really birthed into operations in August of 2016. We are on our 3rd update to the model and just had the 4th update to the model approved for operational onboarding on Tuesday. So it is a system that is intended to mimic the water cycle. We have atmospheric forcings, the rainfall, wind, the other atmospheric variables that control the water cycle. We ingest that information in the NOAA MP land surface model. We couple that to a terrain routing module that we route on the terrain on a 250 meter grid. We aggregate that information in the NHD plus catchments. That's the 2.7 million river reaches. And we route that through our channel and reservoir routing modules. And we use that to produce a forecast. As I've already alluded to, we produce a forecast hourly. That's based on the MRMS quantitative precipitation estimate. And that's the high resolution rapid refresh. These are the atmospheric forcings that we use. The medium range forecast is based on the downscale GFS. That's the Global Forecast System. And our long range forecast out to 30 days, that's based on a downscaled and bias corrected climate forecast system. So the great thing about the National Water Model is that it's able to provide us forecast guidance on a multitude of scales. So the model does run nationally, but we're able to zoom in from the national instance of the model to look at our water resources on a regional scale, the neighborhood scale, and even down to the individual stream scale. The people on this call can go to water.noaa.gov and view the imagery, view information out of the National Water Model. You can click on the rivers and streams that are by your house, and you can get a forecast out to 30 days on what's going on in those rivers. And you can also look at this in all the way up to the national scale. We intend the water model to be, it's not just a stream flow model, it's intended to be a model that captures the entirety of the water budget. So it produces information on stream flow, soil moisture, snowpack, evapotranspiration, among other variables. It produces an incredible volume of information a day. The National Water Model, just in the short range stream flow, that's 18 hours, 24 hours a day, 2.7 million locations. That's over 1 billion pieces of stream flow information, forecast information that we predict on just the short range forecast alone. All of this data is made publicly available through the NOMADS data service. So anybody on this phone call can go pick up the last 3 days of National Water Model data and download that data to continental scale to your local environment and work with that data. This is an animation. Let's hope that this works. This is the National Water Model in action. This is the Midwest floods of April, May 2017 in 2017. In contrast, I think we're all familiar with looking at a weather map and looking at a radar of weather moving across our homes. This is the analog for stream flow. This is stream flow moving through the Mississippi River Basin and even into the Atlantic coast. The lighter blue colors are lower stream flows, and the dark purple on the Mississippi River, those are the higher stream flows. So go into a couple of case studies and highlight what we intend to use the water model for. The April-May floods that I just showed the graphic for, here is the quantitative precipitation estimate based on those floods. So it's a rather large rainmaker, producing up to 15 inches of rain in Missouri and parts of Arkansas. So looking at a location, this is near Tahlequah, Oklahoma, and I apologize for any Oklahoma folks that we have on the phone that I just butchered that. This is 9 days before the onset of major flooding. So we're looking at the solid lines with the symbols in them, the red, the blue, the yellow, and the dark gray. These are the 4 runs of the National Water Model in the medium range forecast. The brown line, the brown solid line, that is the analysis configuration. So that is representing observations from USGS stream gauges. And the black is observation data. This is what actually happened. So you can see 9 days out, we're able to capture with fairly good agreement, a small pulse that happened 2 days from this particular forecast location. There was another small event going over the moderate flood stage that happened on the April 28th. And then the big event happened on April 30th. And 9 days out, one of the members of the National Water Model, the 12 Zulu run of the water model, showed that we could be potentially in a major flood in this area. Moving on, 5 days before the event, there's an initial indication of flooding for this second peak that was completely missed in the 9 day forecast. That's starting to show up 5 days, 3 days before that event, 5 days before the major flood. And now the water model is telling us that there's an increasing possibility of a major flood. This was captured in 2 of the 4 medium range members, and an indication of moderate flooding was captured in a third. So 3 days before the event, there's some new information that's being shown on this particular slide. For the first time, we are seeing our current forecasting capability. The current forecasts were not they only forecast out to about 3 days. So the water model was picking this up well in advance of our current forecasting capability. 3 of the 4 simulations of the water model captured the peak of the major flood 3 days before the event. There's fairly strong agreement on the moderate flood that happened, and now we're starting to see the AHAPS, that's the Advanced Hydrologic Prediction System. We're starting to see that system give an indication of flooding for the moderate event, but there's not enough precipitation in the event to give in that forecast to give give an indication of the major event. So this is the day of the event. There was fairly strong agreement between the National Water Model and the existing forecast, and we ended up doing pretty well. Overall, not every forecast that the National Water Model produces, we can tell this story. But overall, we had some indication of major flooding 9 days in advance, where 3 days in advance, the official forecast wasn't showing an indication of even a major flood. So this shows the power of what the water model can be built into being. It can give us actionable intelligence well in advance of major storm events. So another main benefit of the National Water Model, this gets back to the story that I told on the actionable intelligence. Where can we produce a forecast now that we can where will we be able to produce a forecast in the future where we currently produce a forecast? So if anybody's familiar with the Ellicott City floods in July of 2006, 16, there was another one in July of 2017. Ellicott City is shown by the area, or shown by the white arrow in this graph. We currently have 3 forecast locations around Ellicott City. The two dots in the red and the one in the green. Ellicott City is about 30 miles away from these traditional river forecast points. So it's a very small watershed, just a few square kilometers, if that. And the forecast, this was a very strong local storm. And the forecast at these 3 locations completely missed the event. By the way, the National Water Model, where we provide a forecast, is shown in the yellow on this, and we actually did. Were able to produce a forecast and capture this event. So some of the aftermath is shown in the upper left-hand corner, and this was a very small segment of the Tiber River that was a tributary of the Patapsco. So it's about a 10 square kilometer basin, had severe flash flooding. The flood actually ran through Main Street of Ellicott City. And the National Water Model, so this is the Tiber River in Ellicott City. We were able to predict this event. And that shows that right now we forecast only about 3% of the river miles in the country. We're pushing that up to 97, 98% in the National Water Model, and providing information where no information currently exists. This can be a very powerful tool in the future. The other utility of the model that I would like to highlight is Hurricane Harvey. Never in my lifetime would I think that we are beginning to measure rainfall in feet and not in inches, particularly in one event. We were all a little flabbergasted when we were looking at the forecast for Harvey, where we were seeing 47, 50 inches of rainfall in our forecast. and the Weather Service actually putting this out as our official forecast. It was quite an occurrence. So what we're looking at here is Hurricane Harvey was actually fairly easy to forecast from an atmospheric point of view. We're looking at the National Water Model medium range forecast. You're seeing the atmospheric forcings overlaid with the streamflow forecast for Hurricane Harvey. The National Water Model forecast is on the right. What actually happened, or excuse me, on the left. What actually happened is on the right. So this was generated, I think, 7 or 9 days ahead of Hurricane Harvey. We were able to do pretty well with what actually happened, other than you can see it at the end of the animation. Our early forecast had the center of Harvey going up into the Mississippi River Basin and producing flood events on some tributaries up there. That actually didn't pan out. But the main impact in Texas, we were able to do fairly well in advance of the event. Another major accomplishment for Harvey was, for the first time, we stood up an experimental capability to produce a flood inundation forecast in anticipation of a major storm. And that's what is shown on this particular map for the city of Houston. This is a flood inundation forecast map for the, I think this was 3 days before the event. I don't remember exactly. But this is producing a forecast of the water level, and the emergency management community was using this to provide the emergency response for Harvey. Incidentally, as with the Tahlequah, Oklahoma incident, the National Water Model was producing actual intelligence 9 days before the event. The official forecast did not indicate a major flooding until 2 or 3 days before Harvey made landfall. At that point, it becomes very difficult for the emergency managers to coordinate the response. I'll walk through. We do have a couple of other maps. This is a zoom in of downtown Houston. Again, this is using the National Water Model forecast and producing a forecast inundation map. And this is for Jefferson County, using the water model. This is around the Beaumont, Port Arthur area, I believe. This is showing some of the intelligence that we're able to generate out of the water model. This is still a work in progress. It's still very early on. But eventually we'll be able to support the emergency management community, help them identify where they can stage supplies, where they can evacuate people to in times of crisis. Last one, this is Orange, Texas. So same inundation map. So as I said, we have just handed off version 2.0 of the National Water Model for the operational onboarding process. The National Water Model is fairly early. It's in its infancy compared to the atmospheric models. And we do have a long-term development strategy for the National Water Model. And this is where the Summer Institute comes in. Is we rely on the Summer Institute and the great work that is done through it to help us set some of the development direction of the National Water Model. We have our overall plan, and this is what we affectionately call our Stairway to Heaven. And the Stairway to Heaven, for those of you who don't know, is a song by a band that old people like. And this is kind of our key milestones in development of the water model. first, in fiscal years 19 through or 15 through 19, is standing up the national water model. Then we are bringing in the flash flood and urban hydrology. This is the hyper-resolution modeling that we have enjoyed in the last two summer institutes. The coastal total water level. This is what we're actively working on now in my division, and will be a theme of this year's summer institute. Over the horizon, but not too far over the horizon, is beginning to look at water availability and water quality. We've been in discussions with our friends at the Marine Fisheries Service and their needs for immediate temperature modeling last week and this week, and we're talking about how to potentially begin looking at water quality modeling in future summer institutes. So, as I said, this is what we are currently working on. This is the development trajectory of the model. Version 2.0 was accepted into the operational onboarding process on yesterday. We handed the code over, and it should be live in the late February, early March timeframe. The major upgrade in version 2.0 is that for the first time, we are generating a water resources forecast for Hawaii. Before Hurricane Lane, we had just gotten this capability working operationally the day before Hurricane Lane was forecast to make a direct hit on the Hawaiian Islands. And we were able to use the experimental information out of Water Model version 2.0 to provide emergency response support for the Hawaiian Islands for Hurricane Lane. So some of the developments that we're excited about: hyper-resolution modeling. This was a theme of last year's Summer Institute. We are right now working on calibrating models. We're looking at 2 different models in 3 different basins. We are calibrating both of our models in Charlotte, North Carolina, and doing some bug fixes to that. The reason we chose Charlotte, North Carolina, the storm of record here is Tropical Storm Faye. This is what it looks like in terms of the atmospheric forcings. The Charlotte has a very good network of observation data, and our goal is to be able to produce a model through our hyper-resolution. This is where we're getting down to that street level flood inundation forecasting. Charlotte has a great network of verification data that we can use to evaluate our candidate models against each other. This is the network, our mesh for one of our modeling instances. And this shows you that we are actually able to get down to the street level and resolve some of the features that control how water moves through the landscape on a very fine hyper-resolution grid. The advantage of the vast array of data that we have in Charlotte is that we're going to be able to validate the model not only on a hydrograph and its ability to reproduce a flow in volume and magnitude and timing, but also we're going to evaluate the model against its ability to produce an inundated area. For the storms that we've selected, we have about 2,000 high water marks that we're going to be able to use to evaluate our candidate models against. Another, switching into the theme for this year's Summer Institute, something that we are working very heavily on right now is coupling the freshwater models, the national water model, to saltwater models. Right now, the people who live in the coastal fringes of the country, almost a third of the country's population, do not have access to a total water forecast because the complex interactions between freshwater and saltwater flooding, our current models just can't handle it. So from a service provider, from a provider of information that people can use to make decisions, it's unconscionable to me that a third of our population is not served by the level of information they use to be able to make actionable decisions. So we are working to couple the National Water Model to the ADCIRC STOP system, and we have chosen the Delaware Bay as our initial implementation of this. We have been working on optimizing the model. Do we do just the 2D hydraulic model of the Delaware Bay? What is our best trade-off of accuracy versus computational burden? And we have found that the center case here, a 2D hydraulic model of Delaware Bay coupled with a 1D hydraulic model upstream of the head of tide, this gives us the best trade-off of accuracy and computational burden as compared to a full hydraulic model of the entire river system. So here are some of our initial results. These are for two locations, Brandywine, which is fairly close to the outlet of Delaware Bay, the open water, and Shipjohn Shoal, which is where the bay necks down into the river and estuarine system. Model spin up for Brandywine is on the top, and Shipjohn is on the bottom. Model spin up is on the left. This is where we're initializing our model using current conditions. And the simulation of Hurricane Isabel, whose track is shown in the inset in the lower left. This is our simulation of the total water forecast for Hurricane Isabel using hydraulic modeling capabilities within the National Water Model. We're doing fairly well at capturing the timing, and we're working on improving our ability to capture the peak flow. Another project, I'm sorry I'm going through these a little quickly, I'm trying to make time for questions at the end. But another one of the projects that we're extraordinarily excited about is our project to essentially teach the National Water Model to think like a reservoir operator. Right now we have a fairly simplistic representation of reservoirs in the National Water Model. They're essentially treated just like a bathtub. They fill up, and when they get overly full, they spill out into the downstream river network. And what we have, we're embarking on a project that will adopt a machine learning approach through deep neural networks to train the National Water Model to predict what a reservoir operator will do in response to not only measurable data like reservoir inflow, pool elevation, those types of things, but also what's going on in the watershed around. Is there an irrigation demand? Is the reservoir, does it have a purpose of flood control versus water supply? Those types of things. So we have a case study in the ACF Basin. This is the Apalachicola, Chattahoochee, Flint River system in Georgia, Alabama, and Florida. And what we have done here is we have a really good, long, decades-old record of reservoir operation data. We have 5 different reservoirs in this particular system. We took one of those, the Walter F. George Lake. We took that information out of the system. We used the data from the remaining 4 reservoirs to train the model, and then use that trained model to predict the outflow from the Walter F. George Lake. And you're seeing the results of this initial implementation on the right. The upper graph in the blue, this is the inflow into Walter F. George Lake, and in the lower graph, this is the outflow from the reservoir. The blue is the observed. Again, we had a good long record of data, almost 40 years of data here. And the orange is our model prediction. So we're doing fairly well. We're able to capture the timing, even of the flood of record around day 10,000, or excuse me, the flow of record around day 10,000. There was no precedent for that event, but we were able to capture the timing of it, and we were doing pretty well with the peak of it. So we're proud of these initial results. We've had a second demonstration on a location in the Colorado Headwaters. Same thing. We took one reservoir out, trained the model on the others, used the trained model to simulate the reservoir that we took out for our validation. We're able to do pretty well. This is over about 6,000 days. We're able to do pretty well. Inflows on the top, observed and simulated releases on the bottom. We're still working to dial in the capturing the magnitude a little better, but we're pretty excited by these initial results. Last thing that I want to chat with you about is one of the projects that's going on behind the scenes that is not going to have an immediate impact on the skill of the model to produce a forecast, but is the most important thing that we are doing going forward. We are going to be releasing the National Water Model in an open source development environment. In order to do that, we are modularizing the water model code. Right now, it is a big tarball of a code that is extraordinarily difficult to work with. And the barrier for students, for academics, for our federal partners to work with that code is really high, because you really have to understand all the lines of the code right now to work with it. And we think that that's prohibitive. And so we're going through an effort to split the code into its lowest common denominator so that anybody can take a module out of the water model. And a module is just a physical process, say infiltration into the vadose. Anybody will be able to take a module out of the National Water Model, bring that into their local development environment, suggest physics upgrades to that particular module, and then offer that back to the Office of Water Prediction as a suggested improvement to the National Water Model. And we will evaluate it. If it's an improvement and it doesn't break what works in the model already, then we will consider taking that to and implementing it as part of the National Water Model. So the community out there is absolutely critical to us, and we were working very hard to be able to better engage the academic, the developer community, as well as our community of federal partners in National Water Model development. We don't want to be selfish and have all the fun ourselves. So that's it for my prepared remarks. I really appreciate everybody's attention. I know I went fairly quickly through some dense information on what we're doing, but I hope that this excites you about the Summer Institute and about the great work that you could come here and do and help us contribute to something that is really going to be meaningful for our country's citizens. I do want to highlight that, you know, what I tell people when they ask me what I do, I say right now we're doing the hydrology moonshot. We're doing something that has never been done before. We have put, you know, we've essentially have a satellite orbiting the Earth. We put the chimp in space. We have a long way to go before we put somebody on the moon or on Mars. And we really want your help with that. We want you involved. We want your expertise. We want you to be as excited about this as we are. And we hope that you'll consider spending a summer with us in Tuscaloosa. After all, the summer is the time to be in Tuscaloosa. So I'll close and take questions while I show our national model. This is similar to the animation that I showed you earlier. this is running over the entire water year. So with that, Danielle, do we have any questions?
All right. Well, thanks, Trey, for presenting all that really awesome information. And so far, we don't have any questions coming in. But just to remind everybody, if you go to the chat, you can type your questions into the chat, and then we can answer them. So we'll wait a couple minutes, and then actually, I'll go ahead and switch screens right now. All right. So while we wait for questions, just a couple announcements. This is the website that Trey talked about, where you can find more information on the National Water Model at water.noaa.gov. And then also, our Summer Institute participant applications are now open, and they will be closing January 15th, 2019, but you can get more information on the Summer Institute at CUAHSI.org. And then you can also follow the link to the application on Proposal Space. Additionally, we will have one more cyber seminar in this series on the National Water Center Summer Institute. And so this next cyber seminar will be highlights from two of our past theme leaders, Fred Ogden from the National Water Center, and then Ihab Mesele from Tulane University. And you can see our recorded cyber seminars also at CUAHSI.org in our cyber seminar archive. And if you have any questions, you can go ahead and email me, and my email is down there, dtarena@cuahsi.org. So I don't see any questions coming in.
So I explained everything perfectly. That's great.
Exactly. Very thorough.
Well, if folks do have questions and want to email them to Danielle about the water model, what we're doing, particularly as it pertains to the Summer Institute, and how you might fit in, please feel free to send those to Danielle. I'll be more than happy to answer what I can answer offline of the webinar.
Okay. Actually, we did get a couple questions.
Oh, good.
Yep. So, does the National Water Center have a proactive role in mitigating floods besides forecasting?
No. We do. We are conveyors of information, so we provide the forecast. There are, depending on who you listen to, 24, 25 agencies in the federal government that touch water. Our role in that interagency is we provide the forecast. USGS provides observations. FEMA is the disaster response, emergency response. So no, we do not do any mitigation work ourselves other than providing information.
Okay, great. Thanks for the question, Federico. And then Jeanne, hope I'm pronouncing your name right, says, I don't have a question, but I did think Dr. Flowers explained things very well. So.
Oh, thank you. Flattery will get you everywhere.
All right. Well, with that, like Trey said, if you do have any questions, you can email me, and that's anything from the National Water Center to the Summer Institute. So, and remember, join us 2 weeks from today on November 30th for our next and final cyber seminar in this series. So
yep.
Thanks, Trey, and thanks for, yep.
Danielle, one more thing before we close. I would like to remind folks, if you're planning to attend AGU this year, we'll announce this again in 2 weeks, but there are 3 sessions on the National Water Model. There are 2 oral sessions, and there's a poster session. And I think a lot of the past Summer Institute participants will be there. I will be there. I encourage, if anybody who is on this call is going to be there, please come up and introduce yourself and indicate if you're contemplating joining the Summer Institute. We would love to hear from you.
Great.
So back to you.
All right. Yep, thanks. And everyone, we'll see you in 2 weeks. Have a great day.